So as we know, in last class we studied two effects of change of temperature. That is what solid to liquid change. We used to call it as melting, or also we can say fusion. Same way, liquid to gas change. What we used to call, guys, liquid to gas change is called as
Boiling or vaporization.
boiling or vaporization. So solid to liquid converting, that is what we used to call as melting. And a particular temperature it will be start melting. That what is the point we used to call as melting point.
Melting point.
Same way, liquid to gas we used to call as boiling, and this boiling also we used to call as what? Vaporization.
Vaporization.
Understand? So this vaporization also will start for every substance. It will start at particular point. So that point is only we used to call as what we used to call boiling point. Yes or no? So for every substance, it will be having different. For example, melting point of ice. What is the melting point of ice? It will take 0 degrees Celsius. Yes or no? Same way, what is the boiling point of water? Anyone? Boiling point of water,
100, sir.
which is
100 degrees.
100 degrees Celsius. 100. What is the one more parameter? You cannot say temperature alone. One more parameter also you have to mention. What is that? At 1 atmospheric pressure. Do you remember? At 1 atmospheric pressure. So atmospheric pressure is also very, very important. As I told you, if atmospheric pressure is decreases, then what is happening? Temperature is also decreases. Do you understand? Melting point and boiling points also decreases. Is it okay, everybody? Yes?
Yes, sir.
Yes, sir.
In last class, we studied, these are the things we studied. What is solid to liquid change, how we can do, and what is happening. And same way, in both these cases, temperature is rising or temperature is falling, guys. Both these cases, you can see solid to liquid is also, temperature is rising, and liquid to gas is also what is happening. Temperature
Rising.
increases or decreases. Temperature increases. Yes or no? Now, the next process which we are going to study in our today's class is gas to liquid. That is what you all people know. Condensation. What is to call? Gas.
Condensation.
So that is the third one. So please all of you keep reading. Gas to liquid change. Shall we start? Everyone? So now you can see. So gas to liquid change, that is what the process we used to call as condensation. Okay. So now, is it by increasing temperature or by decreasing temperature? You might understand here itself. Gas to liquid. So it is by increasing temperature or decreasing temperature? Please respond. Decreasing temperature. Very good, Hari. So by decreasing temperature, we can call it as heating or cooling. Decreasing temperature, heating or cooling. Others don't know. Only Hari alone is there. Any other nobody?
Cooling, sir.
Cooling we
Cooling,
can.
sir.
Decreasing temperature we used to call as cooling. So that is what we used to call as gas to liquid is known as what called as, guys? Condensation. Okay. Now let us see how we can perform the activity to prove this condensation gas to liquid, and as well as what is the activity to make it. So the experimental setup. So you can see the process of changing of gas into a liquid by what? Cooling is called as condensation. Now, for example, if we'll take water, steam. What do you mean by steam? Means anybody can tell me steam means what? Water vapor. Is it yes or no? So a water vapor, what is the state of water vapor? What is the state of water vapor? Which state?
Gas.
Gaseous state. It is a gas. Now, by decreasing the temperature, by cooling, we can bring it back into water. That is what it will come as a liquid state. So this is what is an example of, we can say, condensation process. Okay. Now let us discuss what is this condensation, how it will be takes place, and all. So during this change of state, understanding. So it will form what, guys? Gas will form into which state? Gas will form into liquid state. And let us see, when a gas is cooled enough, means by temperature is lowering its temperature, then the particles, they will gain the kinetic energy or they lost the kinetic energy, guys? If the cooling,
Lost the kinetic energy.
what is happening? They'll gain the kinetic energy, lost the kinetic energy, guys. They will lose the kinetic understanding by lowering temperature. Understand, Gokul, Vartani, by lowering temperature.
Yes, sir.
Particles lose the kinetic energy. So if kinetic energy lost, they will move faster or slower? Kinetic energy, they lost the kinetic energy.
Slower.
What is happening?
Slower.
Particles will come closer. Okay, particles will come closer to each other, so that it will be coming back into liquid state. That is what the process we used to call as what? Condensation process. Is it okay, everyone? Yes. So now that is what. So simply we can say condensation is the opposite to someone. What is that, guys? So they will move closer and closer. Finally, they will start being attached to each other. That is what we will say liquid they'll form. Now condensation is opposite. It's a reverse process of something. What is that?
Boiling, sir.
Boiling. Very.
Evaporation.
Yeah, Reddy said. It is what? See, if we'll take boiling, that is what? So condensation, we can say it is the opposite process or reverse process. It is condensation is reverse process to boiling or vaporization. Is it okay? Why means what is mean by boiling? Vartani, at least in chart respond Vartani. What is this Vartani? How many days I should say you? Simply coming and going, no input, no use. So what do you mean by boiling, guys? Liquid.
Heating.
Yeah, liquid is converting into what? By heating, by increasing temperature, it will be converting into what? Gas. Now, reverse opposite. That is what we used to call as what? Cooling. It will be coming back into the liquid. So that is what? That is why we can say condensation is opposite to the boiling. Is it yes or no, guys?
Yes, sir.
Yes, sir.
Now let us discuss how we can study this experiment, sir. For example, I want to make it, sir. Then how to do, sir? Shall we discuss, guys? Now you can see, very simple. So even real life example also we can notice it. So steam or water vapor is coming back into the water. Is it okay? Shall we discuss now? Now, all of you notice.
Yes, sir.
Do you have a fridge now in our home? Everybody is having fridge. Yes or no, guys? Yes.
Yes, sir.
If you get the water inside your fridge by night or early morning, please go and take the bottle and keep it with you. So after few minutes, you can see at the surface of the container, at the surface of the bottle, it is fully filled with the water. Do you notice it, guys? Do you notice
Yes,
it?
sir.
So for example, let us take any kind of a container in our home. Now also, do you have ice cubes in our home? Please respond, everyone. Ice cubes?
Yes,
Yes?
sir.
Go and take, everyone. Just take 2 ice cubes and keep it in one steel glass and bring it near to you. Just go and try, everyone. Let us see.
Okay, sir.
Yeah, just 1 minute I'm giving time. So by the time I will draw, you can go and you can come. Everybody go. Just do it. So this is a real example. If not, again, I will say the some other experiment also so that you can start. So do it, everybody. Go and bring it. Don't simply sit.
Yes, sir.
Yeah. Now, have you taken into the steel glass? Have you taken into the steel
Yes,
glass?
sir.
Yeah, let it be. Now, this is what you can see. So if you notice it, imagine you might be notice it, keep it in your side. Just you can see that now on the surface of the container, you can see it's like a smog it is forming, like a smoke, like a ice, like a drizzling it is forming. You might be notice it. So just you
Yes,
keep
sir. A little
1
bit.
minute. You can see on the surface of the container, you used to get the water droplets. Yes or no, guys? I think by this time, if you have been kept in the steel glass, by this time you might be notice it. You might be getting.
Yes, sir.
Yes, Harish? Have you seen?
Yes, sir.
Gokul? Yes?
Yes, sir.
That is what. So what will happen means, notice it very carefully. Is it our glass is leaking? Is it our glass is having holes? How the water is coming inside
sir.
or outside? That is what?
So
Understand?
Water one, vapor,
That is
sir.
what from the atmosphere. Notice it here. Imagine this is what the container. Now I kept inside the container ice cubes. What is this, guys? Ice cubes I kept. Okay. Now what will happen means in between what is that inside ice cubes are there and this is the container, walls of the container. Yes or no, Hari? So
yes, sir.
here inside low temperature or high temperature, extremely low temperature. Yes or no?
Yes, sir.
Yes or no? Extremely low temperature. It will be like a freeze state. So freeze rise means temperature is what? Minus degree Celsius, minus 10, minus 12 like that temperature. Yes or no? So it will be less than 0 degree Celsius, less than 0 degree Celsius. Is it okay, guys? Please respond. Less than 0
Okay, sir.
Celsius. Now, basically, if we take the air or our atmosphere contains water vapor or not? You all people know or not?
Yes, sir. It contains water vapor.
It is what
Yes, sir.
as gas. Now, when you kept the glass outside, which is filled with ice cubes, now this air will come and will touch that beaker or glass. Is it yes or no? We cannot see it, but it will come and will touch or not? Please respond. Every direction.
Yes, sir.
Come and will touch. So this air contains what? What is the composition of air? We all studied already. What is the composition of air? It contains what?
Oxygen, nitrogen,
Nitrogen, oxygen, carbon dioxide, water vapor. Is it yes or no? Water vapor, and as well as it is also having dust particles. Okay, so dust and etc. etc. Now, these when the air is coming in contact with the surface of the steel container, now this air, it is very high temperature and low temperature. High temperature, at least it will be 32 degrees Celsius. Yes or no? Room temperature. Yes, please,
Yes,
guys.
sir.
Room temperature. So at this temperature also water air contains water vapor. Now when this air will come and will touch this container, so that what is happening? The heat is absorbed by the ice. Is it yes or no, guys? The heat which is
Yes,
present in the air is absorbed by the ice, so that inside ice will melt or it will be still in solid state. Ice will
Melt, sir.
Ice will melt. Is it yes or no, everyone? Ice will melt, so that you can see here the temperature will increase or decreases. Ice temperature will increase. Understanding? Because the heat of the air is absorbed by the ice, so that rise in temperature of the ice will be there. So by the time the whatever the water vapor present in the atmosphere, the temperature fall down. Means it will come less than that, so that it will be converting back into the what? It will be converting back into the liquid state.
Liquid state.
That is what we can see, the drops of the water droplets on the walls of the container. Have you noticed it, guys? Everywhere. So at the drop, the walls of the container, because once this air will come and will hit this, so that it will be lost, the water vapor will lose its temperature by exchanges to ice, so that it will become cool. So heat is removed means what is the opposite to heat reading? Heat is removed. What is the opposite to heat? Cooling.
Cool,
So that is what it will happen. So that is what the same thing will happen. If I will take the heat, automatically temperature will fall, so that it will be converting back into liquid state. Is it okay, guys? Yes.
Yes, sir.
So this is the process we used to call as what we used to call condensation. Now,
Condensation.
all of you see, take your glass and somewhere you might be throughout the glass you are noticing the water droplets. Are you finding?
Yes, sir.
Yes, sir.
Respond. So that is what is happening. Is it the water is coming out from the glass, or it is atmospheric water vapor condensed? Yes, please. How the water is coming out?
Atmospheric water vapor.
Yeah, atmospheric water vapor condensed. Understanding? Condensed into what? Condensed into liquid. That is what we have to call as condensation process. Is it okay, everyone? Yes.
Yes, sir.
Yeah. Now,
Yes, sir.
if not, sir, I can do one more experiment, sir. Any other experiment? First, let us form the vapors. Later, that vapors will coming back into liquid. Is it okay? Shall we try that experiment? Now, for that experiment, what you have to do?
Yes, sir.
You might be know all T-pan. Do you all know T-pan, guys? This is what in movies and all we can watch. T-pan. Kettle, guys.
Yes, sir.
Kettle, all of you.
Yes, sir.
You might notice it. So this is what the kettle. Now, what you'll do means just boil the water in the kettle. So that what is forming here, you can notice it. What is this called as, guys? What is this called as? fumes, water vapor. Understand? So that is what it will be. If you are keep on heating the water with the help of gas, you can see you can try in your home also if possible, but with the presence of your parents only you do. So this is what is this lines called as? Anybody can tell me what is this gas dotted lines? Please respond.
So
Gas.
the water vapor.
Gas.
Say water vapor, or we can say steam. Understand? So that is only we can say water vapor. Okay. Now, when you are heating, liquid is converting into what state, guys? This is the liquid actually.
Gas.
So liquid is
Gas.
converting into gaseous state. Now you can
Gas.
see, I am taking the frying pan. In our home, you all people are having frying pan. Yes or no, guys? Frying
Yes, sir.
pan. Now, you might be notice it from this nozzle, from the kettle's nozzle, you can see the fumes which is coming. Easily we can notice the fumes. Yes or no, it is visible to us. Okay. So
sir.
gas, this fumes can visible to us. You can see that fumes. So wherever the fumes are coming, take one frying pan and keep inside frying pan. You have to keep what, guys? Just what we did now, the same thing. Where you take what? Ice. Now, whenever these hot gases will come and will touch the bottom surface of this frying pan, so that what will happen, Hari? Any doubt, anyone? So gas is having very, very high temperature. Is it yes or no, guys? High temperature.
Yes, sir.
And ice is having what? Very, very low temperature. Now you tell me, heat will absorb from ice to gas or gas to ice? Always remember,
Gas
high
to-
temperature we used to call it as source, low temperature we used to call it as sink. So always heat will transfer from source to sink only. Is it okay, everyone? Source to sink, so that ice
Yes, sir.
will absorb the heat energy of the gas or temperature. So heat energy is absorbed means temperature of the gas will fall down. Is it yes or no, guys? Temperature of the gas
Yes,
will
sir.
fall down and ice will start melting into what? Ice will start melting into liquid, so that we can say, so temperature is absorbed by the ice. Now the liquid, the gas vapors, they will slowly fall down the temperature and they will at the corner of the frying pan from the bottom only, they will be started converting into liquid. So that is what we can again collecting back into the beaker. So this is what we can say. So what we can conclude that, guys, from here. So you can see converting liquid into gas and again gas into what we converted? Again gas into
Liquid.
liquid. This is what. So liquid to gas we used to call it as which process? Boiling process. Understand? So boiling, till here it is boiling. Now after this process is called as what, guys?
Condensation.
Process. Understand, everybody? So this is what
Yes, sir.
everyone need to do. This experiment also with the presence of your parents, you can do this experiment. Is it okay, ready, Harish? Yes, that is.
Sir, so water vapor is pure or non-pure, sir?
This water is very pure, Hari, Reddy. It is not possible to drink also. Only water vapor.
Okay, sir.
Sir,
Yeah, Hari.
if you take the ice cube in our hand means it will observe our body temperature and it will start changing,
Yes,
sir.
very
This is called
good.
which
Now,
process, sir?
put it. Yeah, that is also you can see. Put the ice inside in our palm, so that what is happening? Our body temperature is more. Yes or no, guys? What is our body temperature? 37 degrees Celsius. We already studied, correct? So 37 degrees Celsius. So ice is what? Let us take minus 10 degrees Celsius. What is happening? So this heat, our body temperature is absorbed by the ice. So that what is happening? Ice temperature will increases and will come to more than 0 degrees Celsius very fastly. Yes or no, guys? Yes.
Sir.
So that is why you can see the ice cube will start melting into our hand in our hand faster. But if you'll apply the more pressure, what will happen? More it will be melted. Yes or no? If you'll apply with the hands, both the two hands, if you'll proceed, then pressure is increases, melting also what is happening? Melting also will increases. Understand? So much fastly we can melt the ice in our farm while we are applying more force. Is it okay, guys? Yes.
Sir, this is
Yes, sir.
concentration, sir.
Yeah, converting, that is what. So converting this ice, that is what exchanging of heat, that is what we can say condensation. Okay, Hari?
Okay, sir.
Yeah. So that is also we can say condensation. But best example, now you see our glass, your steel glass, full glass surroundings is filled with the water, I think. Is it my guess is true? All of
Yes,
you?
sir.
Yes, sir.
Yeah, that is the process. That is what atmospheric water vapor is condensing back into liquid by using that process. So any substance, it will keep the cool substance inside the container. So on the walls of the container, it will be water vapor will be condensed back. That is what atmospheric water vapor. The process is only called as condensation process. Is it okay, everyone? Yes,
Yes, sir.
that is
Yes,
the
sir.
experiment. So this is what we can come to conclusion. So what is converting gases to liquid? That is what condensation process. Next process. What is the next process? Last experiment. Anybody can tell me? Fourth experiment. Now it's over. Then what is the next experiment? You have to speak, guys. What is that?
Gas to solid.
Liquid solid. Understanding? So liquid to the solid. So liquid to the solid, what is to call your, if you want to ice from the water, your mother will say, keep the water inside the
Freezing.
where? Keep the water inside the
Fridge, sir.
fridge. That is what is to called as solid to liquid to solid change is called as freezing. What is to called, guys?
Freezing.
Freezing. Understanding? So now, same way, remember a temperature which the water vapor converting back into liquid, or else any substance from gas to liquid, that point is called as condensation point. What is to call? Condensation point. Understanding? At a particular temperature where gas will start converting into liquid is called as condensation point. Is it okay, guys? Yes, please respond.
Okay, sir.
Now, what is the condensation point of water? Anybody can tell me? What is the condensation point of water? Water.
100 degrees.
Zero.
Less than 100 degrees Celsius. Understand, Hari? More than, greater than 100, water vapor. Less than 100, 0 to 100, it is liquid state. Yes or no, Hari?
Yes, sir.
That is what. So condensation of water is how much? 100 degrees Celsius only. Understand? So less than 100, liquid state. More than 100, what is that? More than 100.
Water vapor.
Water vapor.
That is what you have to remember. Same way, liquid to the solid we used to call it as freezing. So now, what is the melting point of water? Melting point of water. Ice.
100 degrees Celsius.
Melting point.
100, sir.
I'm asking boiling point. Melting
sir.
point. Melting point is how much? 0 degrees Celsius.
0 degrees.
So if it is less than that, what is happening? What is the state of that? Less than that, it will converting into ice. Is more than that, what will happen? More than that means it will be converting into liquid water. Is it yes or no, guys?
Yes, sir.
Yes. Now, freezing. Freezing means what is the freezing point? Then at a particular temperature, where a substance will freeze us, is called as freezing point. What is to call? Freezing point. Now you tell me, what is the freezing point of water? Example. Freezing point of water. How much, guys?
0 degrees Celsius.
Freezing point of water, if we'll take 0 degrees Celsius. Understand, Radhanishka, Arun Kailash? Ready? That is what you have to remember. You might be notice it, for every substance, melting point is equals to freezing point. Please note it down. Solid to liquid, whatever the melting point, the same thing, liquid to solid, that is what we used to call as freezing point. Purima, understand, Ra? So you can say example. So melting point of water is how much, Ra? Melting point of water is 0 degrees Celsius. Understand? Same way, freezing point of water also how much, guys? 0 degrees Celsius. Here, greater than 0. Understand? Greater than 0. And here what will happen? Less than 0. Is it okay, everybody? Please respond, yeah. That is.
Sir.
Yes, sir.
Yes, sir. Sir, melting point of ice cube is 0 degrees, sir.
Yeah, melting point of ice. That is what water. We can say bracket ice. Okay, Hari? Prema, that is what you have to remember. Same way you can see. So from that we can conclude it. For every substance, melting point is equals to what? Melting point is equals to what, guys? Freezing point. Prema, freezing point. Same way you can take. Next, liquid to gas. Liquid to gas, what we used to call? Gokul, Vartani. Liquid to gas we used to call as?
Condensation.
So at the
Boiling.
particular point where the liquid will converting into gas, we used to call it as boiling. Same way, a particular temperature where the gas is converting into liquid, that is what we used to call it as. What is that called as?
Condensation point.
Understand? So what is it called as?
Condensation.
Example, if we'll take, so boiling point of water, how much guys? 100
100
degrees.
degrees.
Yes. Understanding? Next, condensation point, CP of water vapor. That is what converting into water vapor is converting into liquid state. What is that, guys? What is that? That is also what? 100 degrees Celsius only. Understanding? Less than that, it is liquid.
Yes, sir.
Now you tell me. So from that, can I say boiling point is equals to condensation point? Arun Kailash? Boiling point
Yes, sir,
is
we can say so.
condensation point. So this is the main important thing which I want to say you. For any substance, melting point is equals to freezing point. Same way, boiling point is equals to condensation point. Is it okay, guys? Yes.
Okay, sir.
Yes, sir.
Please note it down. Very, very important one. So now if you'll understand this concept, then the last experiment which we have to prove, that is what is that experiment? Liquid to the solid. Yes or no? So now let us discuss what is this
Sir.
solid. Ready? Danishkar Kalra. Liquid to solid, and what is the experiment we have to do? That is all we will discuss. So liquid to solid change, we used to call it as what, guys? Freezing, we can say. Understanding? So what do you mean by freezing? In our own words, anybody can tell me what do you mean by freezing? If you freeze something, either it will be solid or liquid or gas state, it will freeze. It will freeze. Yes, please
Solid.
respond. Solid state. Understanding? Particles
Solid.
will
Degrees in
closer. That is
temperature,
why.
sir.
Freezing is, understanding, freezing is also known as, okay, also known as solidification. What was to call, guys?
Solidification.
Okay, that is what you have to remember. So means freezing is also increasing temperature or by decreasing temperature? By
The degrees in temperature.
temperature. Understanding? Decreasing temperature. And also you can notice it here. Kinetic energy also will decrease or increases. Kinetic energy of particles
Increases.
also decreases. That is what will happen. Is it okay, everyone?
It will come closer.
Yeah, and particles will come closer and closer and closer, and they'll become tightly packed. That is what we can say solid. Yes or no, guys? Yes.
Yes, sir.
Yes, sir.
So this is what you please note it down, and you can see what do you mean by freezing. I'll say the definition. You can write it. Freezing. The process of changing a liquid into a solid. The process of changing. The process of changing a liquid into a solid by cooling or heating. Arun Kailash, Gokul.
By cooling, sir.
Cooling, sir.
Yeah, by cooling, comma, is called freezing. Is called cooling. Is it okay, guys?
Yes, sir.
Yes, sir.
Yeah, that is what you have to remember. So that is what the melting point it will take. So for example, melting point of ice if we'll take. What is the melting point of ice? We already know that. Melting point of ice is how much?
0
0.
degrees Celsius.
Same way. What is the freezing point of ice?
0 degrees Celsius.
0 degrees Celsius. That is what. Okay. And if we'll take the boiling point of water is 100 degrees Celsius, and if we'll take the condensation point of water is also equals to what?
100 degrees
Point
Celsius.
also equals to what? 100 degrees Celsius. Yes or no? Yes or no, guys?
Yes, sir.
That is what will happen. So this is what is freezing. So you can do that experiment. You can take the ice and you can if you take the water and if you keep inside the freeze, what will happen, guys? If you keep inside the
It
freeze,
will
what will
become
happen?
into
It will
ice.
become solid, sir.
It
Ice
will be
cube.
cooling by loss its kinetic energy, temperature. So the particles will come closer. So after 1 hour, you can see what will happen, guys. If you keep in the freeze, deep freeze, you can see it will be turns into ice. Is it yes or no, guys? Yes.
Yes,
So
sir.
that is what we used to call it as freezing process, we can say. So that is what, so from this we can conclude for this all the four experiment, we can say the state of matter can be changed by two ways. What is that? One way, guys, by heating and as well as by cooling.
Cooling.
Yes or no? So that is what you have to remember. So the state of matter can be changed by changing the temperature. So changing temperature means what, Gokul? Only increasing temperature or decreasing temperature? Both. Understand? So by increasing
sir.
temperature also we can convert, by decreasing temperature also we can convert. That is what will make a complete picture for to understand this complete state of conversion. So please all of you put a statement, right? All of you have understand liquid to solid change, freezing. Understand? So this is why
Yes, sir.
lowering its temperature or increasing temperature. Lower its temperature. Okay. So lower its temperature, what will happen? Decreasing temperature also decreases the kinetic energy. So particles will come closer or will move